There we go. Cool. Okay, so start quiz.
Real quick. Okay, so information, normal probability applet. That's probably what we're playing around with. Let's see. Oh, that's from last week. Okay, perfect. So we got that up if we need it. Do not round until your calculation is complete. That's important. It's amazing what rounding can
Seriously.
up. I am taking a computer science class right now.
Uh-huh.
And our latest assignment was um, we're doing kind of budget stuff. And so it asked for your input, like how much do you make? How much are you spending on this and stuff?
Mm-hmm.
And the very last thing that we just did was we had to write out a function that would calculate how much tax you owe depending on how much you make. And it was amazing how many people were having troubles with it, getting the wrong numbers
Uh-huh.
because they were rounding to like 3 digits instead of five. And so
Oh,
like it was a pain. And yeah,
yeah.
so that's the thing is you do not round until your calculations are complete. You just put the huge numbers in, and then when you get the final thing, you round to 3 digits or something.
Yeah, that's crazy.
Okay, so which of the following is the best statement of the law of large numbers? So give me not necessarily the definition, but in your words, what is the law of large numbers? And we'll see which one matches with that.
Um, are you on question 3?
I am on, oh, I'm taking the homework quiz. Sorry about that.
You're good. I was like, wait.
Yeah, I should have realized. I'm like,
No, you're
I'm
good.
missing the first two questions.
You're totally fine.
Okay, quizzes. Lesson 6 group meeting quiz. Okay, there we go. Okay, true and true. Probability applet. Okay, there we go. Okay, so in taking a sample size of n equals 5, what is the shape of the distribution of means? So we're looking at a population of means,
Mhm.
the mean of means. So population of means histogram when the parent population is right skewed. First off, before deciding whether it'd be left skewed or right skewed, we'd have to decide, is it going to be skewed?
I don't know.
Okay, so the central limit theorem
Uh-huh.
talks about this. Do you remember what it says?
So there's two concepts. The first concept is I've kind of combined them all into one.
Mhm.
But so if it's a normal distribution, then the distribution of means is going to be normal. If it's not normal, so if it's skewed, if the parent population is skewed, but they have a number over 30, then it will be a normal distribution.
Okay, perfect. So what's the sample size we're looking at?
5.
Is that enough to compensate for a skewed parent population?
No.
Okay, so then that comes down to, does the sample population mirror or invert the skewing of the parent population? So if this is skewed right, will
Mhm.
the mean population be skewed right, or is it going to reverse it and be skewed left?
I think it'd be skewed right.
Okay. And that's, yeah, I can't think of any rules about that, but just the experience of playing with the app,
Uh-huh.
that's what you saw, was that it mirrors the parent population.
Yes, exactly.
Okay, so save that one. Okay, when you're taking a sample size of n equals 100, what is the shape of the population of means histogram when the parent population is right skewed? And you've already answered this one.
Normal.
Exactly. And why?
Because it's over 30.
Exactly. Perfect.
Sweet.
Okay, when you're taking a sample size of n equals 5, what is the shape of the population of means? I just like that better than distribution of means. That sounds distribution of means. That sounds like my brother's what's the word? It's not an electrical engineer or a mechanical engineer. He's a production engineer or something like that, like where he makes workflow more efficient for companies and stuff. And distribution of means sounds like a phrase he would use.
Yeah.
And I was just like, shut up. I think population of means makes more sense to me because we're looking at just that, a population of means. So
Yeah.
are you okay if I say that?
Yes. So
Okay.
whenever you say population of means, you just mean distribution of means, correct?
Yes, because distributions of basically the full phrase really should be the distribution of the population of
Population
means.
means. Yep.
Distribution sounds a little too abstract for me, and
Mm-hmm.
distribution of population of means is just kind of a mouthful. So
Yep.
I like to say the population of means.
No, totally. Yep, I like it.
Okay.
So would this be normal as well?
And why are you thinking that the n is only 5?
Um, because it's a normal distribution, so no matter what the size is, it will still be normal.
Exactly.
Okay.
Okay. Question number 6. When you've got a sample size of n equals 100, what is the shape of the population of means when the
Normal.
parent population is normal? Yeah. You're just asking the same thing over and over again.
Yeah, really though.
I think got that nailed down, though. That's not bad. Okay. When would the distribution of means be normally distributed? Choose all. So this is the what? Fourth, fifth question on this?
Seriously though.
Because yeah, we had the first two, then we had 4, question number 5. Okay. Data from the population. So the population is normally distributed. We know that no matter what.
What it will be normal.
Exactly, yeah. Data is
Love.
drawn from the population that is normally distributed. Again, we don't care about sample size. We know it's going to be normal.
Yes.
Data is drawn from a population that's right skewed, and it's going to mimic its parents unless it's n greater than 30, but we have a small size. So this one
That
is
would
known,
be
and this one right skewed, but large. So we know that the large can overcome that skew.
yes.
Any questions on those? Because like I said, that question was just pretty much the last 4 again.
Yeah,
And
no, that
you
makes
nailed those last 4.
yeah.
Okay. Which of the following gives the best explanation of the central limit theorem? So looking at these real quick. Okay, what do you think the answer is? If you've had a chance to go through them all.
Yeah, give me a second. I have to think about this. Is it the last one?
So if the sample size is large, the shape of the distribution of the sample means will be approximately normal. And we know that. How is that different from the first answer?
Um, so I don't like how this one said, oh, you know that sample size is large. I don't know. I guess the last one talks more about the size of the sample, and the first one just talks about, okay, if the parent population is normal, then the distribution will also be normal, no matter what.
Which isn't, that's true though, right?
Those are both true.
Yeah.
Okay.
Honestly, this question has me a little confused. Let's do the last one and come back to this. We
Okay.
have a bit. Because I think you're right. There's something weird about that wording that makes the last answer just seem more correct.
Yeah.
But I hate it when it's like, choose the best answer, which means choose the more correct. And you're just like, no, give me wrong answers and a right answer.
I know, seriously
Don't
though.
make me choose the more correct.
Okay, we'll come back to number 8.
Okay. Be a random variable.
Uh,
Number 9. What do you got for the answer?
is it 10?
Why do you say 10?
Uh, it says mean equals 10. I don't know.
So this is the mean of the parent population, and this is asking for the mean
The
of the sample
samples.
population.
How would I get this answer?
Well, remember,
Am I
so
using?
this is giving us a sample size.
Uh-huh.
It hasn't told us how many samples they've taken.
Yes.
So if they haven't told us how many samples they've taken, just assume that they've taken thousands and thousands of samples.
Okay.
And if you remember the app, when I hit the 10,000 button over and over again, what happened to the mean of the sample population versus the mean of the parent population?
I mean, they got closer together.
Exactly. So yeah, you're right. It is 10.
Okay.
I just wanted to make sure you understood why you're right.
I was kind of guessing actually. So.
Okay, then I'm glad we went over that.
Okay.
Because yeah, they said we took a single sample of n equals 36, then I guess technically the answer would be still be 10, but
Yeah.
you'd kind of want them to give you the numbers. When they don't say how many samples they've taken, though, I'm just assuming that they've taken tons and tons of samples.
Yeah.
And you saw that it was seriously, it was like, if you have a large number above 25, and we're dealing with 36 here,
Yeah.
when you have a large enough number, you hit like 20 samples or something, and it's pretty much dead on.
Dead on. Yeah. Exactly.
So I'm just assuming that they've done tons of samples in this example. Okay, standard deviation. So not this standard deviation up here where it says sigma is equal to 6. It's asking for the standard deviation for the population of means.
Um,
Do you remember the equation for that? It's a short one.
isn't it like n squared or something?
You're close.
It's like, what if I have it written down? Okay, is it um sigma over n squared?
Oh, you're so close.
Dang it.
What do you do to n?
Um, oh, you put in the little thing.
And what's that little thing?
The thing. What is it called?
So it's not a square, it's a square root.
Square root. There we
There you
go. There
go.
we go. Okay, so that's how you get standard deviation. Okay.
Yes. And so there's only two variables that we need, sigma and n, and we have them both right up there, 6 and 36. So just a quick calculation.
So it would be Need my other calculator. Hold up, I have it in my book bag. Okay. So it's going to be 6 divided by 1.
Exactly, yeah.
Okay.
Because the square root of 36 is 6, so 6 divided by 6 is 1.
Oh, I had to get my calculator out.
No problem. I actually did it in Excel, and then I realized, wait, 30. So the square root of 36 is 6.
Oh, I should have done that, but if I do that, I'll probably end up doing the math wrong or something eventually. But anyways.
Okay, so they're asking this yet again.
Normal.
Exactly. So expect that on the test because that's pretty much the 7th time they've asked that.
Seriously, though. Hey, I'm okay with that. I got that down.
And the theorem that would justify your response to the last question, there's just 2 theorems. There's just 2 laws in this last. Exactly.
Dang, we good. We're super good.
Okay, let's see if. So let's submit, see if we missed number 8, because that one was a little weird. And 8, nope, you're right on that one.
Woohoo! Honestly, I don't know what the difference is between the first one and the second one, but.
Oh, wait, dang it. We did get 12 wrong, though.
Wait, what?
Have you submitted?
Yeah.
Oh, okay, then you missed that point, too.
Wait, isn't it law of large numbers?
No, and I totally got caught up, too, because I saw n is greater than 30. What does the law of large numbers specify?
The sample size.
The
So
sample size correlates with what? So the larger the sample size, the what?
the smaller the standard deviation.
Exactly. This was asking about the shape, not the standard deviation. So we just totally both overlooked that.
Oh, dang it.
We both totally understood the concept, but I just saw n greater than 31. I'm like, oh, that's a large number. Law of large numbers.
Yeah, it like kind of makes me worried though for the test because I really feel like I understand it, but I feel like I'm gonna make like stupid mistakes on the test. I'll be like, Sister Cook, you don't understand. I know this stuff.
Well, just make sure, because like, yeah, we blitzed through this. Just make sure that when you're taking the test, when you're finished, go back and literally retake the test.
Yeah.
Like that's what I always have to do is I take a test and then I start from square one. Luckily, there's not really too many calculations on this.
Yeah.
But yeah, like when I was in calculus, I'd like start over, literally get rid of all my scrap paper so I'm not influenced by it and just do the test all over again to make sure that my answers matched up.
Yeah, that blows my mind.
So it's a time meter, but the fact is
you get more grade.
It saves you points, and yeah. I'd rather spend, taking extra, stretching a 2-hour test into a 2-hour and 45-minute test and up your grade by 5 or maybe even 10%, than to take that loss,
Yeah, exactly. It's worth it.
Yeah, because there's a huge difference between understanding the concepts and just making human mistakes, like we both just barely did with question 12.
I tend to do it a lot, so.
So that's one where it's just both of us. We're like, large number. So just make sure, when the test comes up, I'm planning on taking the test twice, so don't worry about that.
Yeah. Yeah,
but,
no, I'm going to do it too, so.
But it sounds like you've totally got this nailed down.
Yeah, no, you explained it super well.
Okay.
Honestly. Thank you.
So the homework quiz, yeah, both homework quizzes aren't due until Saturday, right?
I think so, yes.
Okay, so yeah, just take the homework quiz, and if you miss any of them, and if you have any questions where it's not obvious, we'll
Yeah.
talk about it on Thursday.
Okay.
Because yeah, because last Thursday homework, like I said, you totally understood conceptually. It was just dumb little mistakes.
Yeah, yeah. So, all right, cool.
But
I will actually probably take it right now. What's fresh in my mind.
okay, perfect.
Yeah,
And then yeah, because now you know how to pull up your submissions. So if you miss some that just don't make sense, we can go like you can just pull it up, see what your answers are, and we can go over that on Thursday.
yeah.
And then I would recommend, while it's fresh on your mind, before doing your first submission,
Hmm.
email Sister Cook.
Yeah,
I'll email her too because that was really weird. Like
yeah,
it's you follow step by step and it gives you the wrong answer. And
yeah,
although she's probably heard from other students too, but it's not going to hurt to shoot her off an email.
yeah. Maybe I'll get points back.
You probably will because honestly, like you did everything right.
Yeah,
It was just there was something wrong with the app. And I honestly
yeah,
don't know what was wrong with the app. So
yeah.
I'd be surprised if she didn't override the grade and get you that point back.
Yeah, I would too. But cool. Thank you for all your help, and I'll see you Thursday, same time.
Yes.
Cool.
Okay.
Cool, cool.
Hasta
All right.
luego, Sarah.